And engineering is a discipline that can take you in many different directions. So Eric's an engineer, you saw his career, a lot of running businesses, sales, marketing, not what a lot of people would expect to find an engineer doing. But you may or may not be surprised to know if you join Timken as a sales associate at Timken, you have to be a degreed engineer. Because all of our sales folks are in fact degreed engineers, because we're a very technical company, you're selling a very technical product. We want you to be able to talk intelligently with the customer and not just point to the line item in the catalog and say, you need one of these. So, engineering. For me, engineering has been an adventure, and it's been a career, and for me, it's been a way to make a difference in the lives of many people, not only in terms of the products that the company I work for manufactures and puts out into the world around us, but as a senior leader now at Timken, with a large team of people working for me, I have the ability to influence their lives on a daily basis, both for the good and the not so good. So that's something that I think about a lot. Who was at Engineer for a Day at Timken? Okay, well, you guys, you're gonna, no answering the questions, because I stole shamelessly from the stuff I use for Engineer for a Day. So I'm gonna base what I'm gonna talk to you about around my desire to go fast. So, who likes to go fast? Anyone got a need for speed? Yeah, so I have the high-powered motorcycles and still working on the Jag or the, well, I got one Jag, but it's an old one. I want one of the new ones, the F-Type, right? But anyway. So, you may or may not have heard of this project, which is going on in the UK right now. Anybody heard of Project Bloodhound? Okay, this is one of a handful of world land speed record attempts that are currently going on. The Americans have got a team, the Brits have got a team, I think the Australians have got a team together. They're all trying to break the land speed record. So when we think about speed, and I'm going to use what these guys are trying to do to point out to you all the different opportunities for engineers and how engineers are making this a possibility. And without engineers and all the different roles they play, things like this project wouldn't be able to be accomplished. So let's just think, without a machine, so a person on their own, how fast can somebody go by themselves, just under leg power? We've got 14 miles an hour, a bit quicker than that. 27 is getting really close. It's in between the two. Who knows who's the fastest man on the planet? Usain Bolt. And in 2009, he ran 100 meters in, anybody know? 9.58 seconds, and he maxed out at just over 28 miles an hour. So that's the fastest man on the planet, 28 miles an hour. All right, now let's get some machinery on board. So how about a bicycle? So now we've got some mechanical advantage. How fast can we go on a bicycle? 50, very close. Yeah, it's about 48. There's a Brit, a guy called Sir Chris Hoy, he's 11 times world champion. He can go 48 miles an hour on a bicycle, and he's the fastest man on a bicycle, unassisted. There are people that have followed trains and other things that have gone faster than that, but unassisted, 48 miles an hour. And then you get into vehicles and cars, and then what this is about, which is the land speed record. So here's some stats, and I'll leave this presentation, so if anyone wants this, you can get a copy. There's nothing in here that's proprietary, and there's some interesting facts and figures in here. So there's Usain at the top, 28, there's Chris Hoy, 48, and you see all other objects that go very fast, machines that we have built as a civilization, right up to the fastest thing, which is the Saturn V rocket. In fact, I think the fastest thing we ever built was the Apollo capsule, Apollo 11 or 12, I forget which one it was. But its journey to the moon was the fastest machine that the planet we've ever made, from the people on this planet at least. So this is the land speed record then. It started back in 1898. Difficult to read back there. I think the first one was something like 38 miles an hour was the first land speed record. But it was only 10 or 15 years after we'd invented the car that people said, how fast can we make these things go? Because originally they were horseless carriages, right? So they weren't supposed to go much more than about 4 or 5 miles an hour, which is what your typical horse-drawn carriage went. But very quickly people figured out how to make them go faster. Up to where we are today, which is the land speed record, which actually broke the sound barrier. A guy called Andy Green in Thrust SSC, almost 20 years ago now, went supersonic. The only time man has ever gone supersonic in a ground-based vehicle. And now they're trying to go faster. So, hopefully Ken, can show us a video. Yeah, I have to go to screen mode for the link to work, I think. Come on, YouTube, don't let me...
Silverado Truck Month, where you can get great offers on select Silverado 1500s, the most rewarding pickup.
I always worry about YouTube, you never know what else is going to...
Humans are obsessed with speed, really, and I think what's interesting is that the land speed record and speed records in general, I think, mirror our evolution in human development. So if you look back at all the developments we've made, a lot of it's been about speed, the technology, so fastest trains, fastest cars, fastest planes, even fastest spaceships. This is all mirror the fact that we are evolving all the time and technologically becoming more and more advanced. And that story is the story of speed.
The outright world land speed record is so iconic because it's the simplest, purest, oldest form of motorsport. The easiest thing to understand, it is simply driving a car faster than anyone else in history. When I was at university studying mathematics and learning to fly aeroplanes, I was watching Richard Noble attempting and then breaking the world land speed record in thrust 2.
The wonderful thing about that car was we achieved its design speed, which was 650 miles an hour. We peaked out at 650.88, so it was very satisfactory. And suddenly the data arrives, and we discover I was within 7 miles an hour of takeoff, so it was a lucky escape, but a new world record. As a result of the skills that we all acquired one way or another from the Thrust 2 project, we now realise that these skills could be applied to other projects.
In 1994, I was a serving Royal Air Force pilot, sitting at a main base in the UK, reading newspapers one Sunday, and I saw the public launch of a new world land speed record project, the Thrust supersonic car. One of several teams that was attempting the record during that period in the 1990s. This one was different. This one was twin engine. This one was going to be supersonic. And one line in that article said, Richard Noble, the project director, is looking for a driver. That became me.
And he's an incredible character. He's got 3,000 hours of fast jet time. He's got first-class honours in mathematics. And we're very, very fortunate that he decided that he wanted to join us. And I think the great moment for all of us was the first time we broke the sound barrier. That was a fantastic thing. And you see this car coming up faster than any jet fighter you've ever seen, like a huge black locomotive airing down the desert. And I would be standing in the midpoint of the desert with all the media and everybody else and watching all this. And it just reduced everybody down to prayer.
The thrust cockpit was between the two huge Spey engines. I was very much sitting down in the valley with only a narrow tunnel to look forward between the engines and down the 13-mile track that we were driving on. Conventional steering wheel, but model an aircraft steering wheel with buttons on it for parachutes, radio, etc. Right foot controlled the throttle pedals with a total of 100,000 horsepower from the two Spey engines.
And this car comes out faster than any airplane you've ever seen in complete silence. And then suddenly it's alongside you and a huge double bang, ba-boom, like that. And a wall of noise and it just disappeared.
It's because it was so powerful that 10 miles off the end of the track, the local town of Gerlach was experiencing what they thought was earthquakes. You can't hear your own shockwave, you can't hear your own sonic boom. That's what it's like in a jet fighter, that's also what it's like in a supersonic car, which unfortunately means I'm the only person in history that has never had the opportunity to hear a car make a sonic boom.
Turn run 1.020.
We finished with thrust SSC. So there we are in the pub, having broken the sound barrier, and we all look at each other and say, we're never, ever going to do this again.
I joined Bloodhound initially as a consultant, talking about the option for how we would build a faster car, possibly. We'd heard there was competition, the Australians, the Americans were both planning records, and it was very much still an informal conversation. It didn't become a serious conversation until we spoke to the British government and discovered a crying need for scientists and engineers. The biggest problem we've got is bringing science and technology to life for kids at school. Here was something the land speed record could do, and do brilliantly. All of a sudden, Bloodhound SSC and its education program had a purpose, and at that stage, when we looked at who was going to drive the car, I was initially trying to find a way of choosing the driver, and realised that the previous driver, the current record holder, would be the best qualified, whatever kind of test you did, and of course that was me. So I had a chat with the team, and here I am.
Well, of course, we had our first meeting with Ron Ayres, and Ron was absolutely appalled, and he said, how fast do you want to go, Richard? And I said, 1.5 times the speed of sound. And he said, no way was he going to be part of this. So a bit of horse trading went on, and we ended up with Mach 1.4 thousand miles an hour. A huge, massive project. Massive because basically what you're doing is creating the equivalent of a jet fighter. It will accelerate a jet fighter. It goes 200 miles an hour faster than the Eurofighter at the same level, where 3,000 feet here is pretty thick. So, you're really pushing the boundaries of what's possible on just about every single front. We've been joined by the Norwegians who are doing the rocket motor. The jet engine, of course, has come from the Ministry of Defence. And there's a very good chance we're going to be rolling out that car in about July next year.
So that's actually July this year. So the car has been built, and they will be starting test runs later on this year. And then they'll be going out to South Africa next year. They found a 15-mile stretch of dried lake beds somewhere in South Africa that they think is a good spot for the run. So hopefully good luck to those guys. Who knows what the speed of sound is?
The speed of which sound travels.
Correct. All right, so I was looking for a number actually, so good answer. Yeah, he knows what the speed of sound is. Anybody know what the actual value of the speed of sound is? At sea level, because that's a variable question. Well, it depends on atmospheric conditions and what have you, but it's somewhere around about 770 miles an hour. So that car that you saw run there went faster than that. Now they're attempting to go 1,000 miles an hour. So you think about the role that engineering plays. Whether you are an aerodynamicist, so maybe you've got a degree in mechanical engineering, and you've got fascinated by how flow works, whether it's liquids or air, then someone that pays attention to the aerodynamics on that vehicle would have come from an engineering or a pure science background. The fuel, so there's two engines in this thing. One's a jet engine, gas turbine engine. That gets it up to about 400 miles an hour, and then they light off a liquid-fueled rocket. Those two engines between them, 135,000 horsepower. Who's got a car? Do you know how many horsepower your car has? Well, I would guess, unless we've got any really souped up machines here, probably somewhere in the 200. If it's just a regular, Toyota Corolla or something like that, it's going to be a couple of hundred horsepower. This thing's got 135,000 horsepower. So chemical engineers working on the fuel, mechanical engineers, physicists working on aerodynamics, the actual structure of the machine. How do you stop this thing from flying? As I said, it's faster than most fast jets. It wants to take off. It doesn't want to stay on the ground. So that's one of the biggest challenges they have, is how to keep the thing on the ground. So a lot of science, a lot of engineering. So we'll leave Project Bloodhound, and I'll just wrap up by saying, from my standpoint, if you have a strong mathematical background, an interest in fundamental science, then there is a whole plethora of technical careers that can open up to you if you choose to go into a technical degree program of some sort. And as I said before, the degree that you get is just a starting point. Where your career takes you after that is up to you. I would also strongly encourage you to consider a technical career. because I have 5 openings that he's not been able to fill for me yet in HR, looking for technical people at all levels. Junior engineer to work on thermal treatment, so this is a manufacturing process. We take steel and we bake it in an oven to change its mechanical properties. That changes how our products perform. The science behind that, I'm looking for an engineer at a sort of entry level to come in and work on those types of projects. Position's been open 7 months. Interviewed a whole bunch of people. Nobody has even close to the right background. So, as I look at my group today, there's a bunch of people like me, lots of grey hair, you know, that over the next 5 to 10 years are going to be retiring. And I am really concerned, not only for Timken, but for the United States. Where is this next generation of technical people coming from that is going to continue to fuel the innovation and what is ultimately the backbone of the heart of the economy of the United States, which is manufacturing? Huge gap. So you've got companies now starting apprenticeship programs to encourage students to go into vocational school. That's where I started. I've been with Timken 40 years, but like Rob, I started as a toolmaker, an apprentice toolmaker. But I started that because, well, I hated high school, wanted to get out at the earliest opportunity, which in England you can legally do that at 16 without being labelled a dropout. And I went to vocational school, but with Timken. So I joined Timken at the age of 16 on an apprenticeship program. Part of the deal was, we train you during the day how to do machining and what have you, and then you go to school at night and you get an associate's degree. So by the time I was 18, I got an associate's degree, and so this was my plan. I mean, when I left, just because I hated high school, that was a whole different story, but my plan was get an apprenticeship and get my education whilst working. So I got my associate's degree, that got me onto a bachelor's degree program, did my bachelor's degree, and then I actually went on to finish my doctorate. So I got a PhD. And then my career, as Rob said, you know, my career at Timken has really taken me from starting on the shop floor, working in the tool room. I went into shop floor supervision, so I was a manager very early in my career, and I really enjoyed that. I like working with people. But I also realized the environment I was in, technology was moving so fast that if I stayed there, that was basically going to be my career. I would have been in management for the whole of my career, and at 22 years old, I wasn't ready to make that decision. So I actually jumped ship, and I was fortunate that I was at British Timken site we used to have in the UK, and we had a large research group, and they were looking for project engineers. So I moved into the research area, and that's what allowed me to get my PhD doing research. And then from there, gradually rose up through the research ranks. That's what brought me to the States 20 years ago on the infamous temporary assignment, and I've been here ever since. And then whilst I've been in the States, I've had 9 years in our aerospace business, initially in an operational role, so out in the manufacturing plant, but then I moved into product development and had 3 really fun years working with the Air Force and Pratt & Whitney, developing mechanical systems for the F-135 engine, which is the engine that goes in the Joint Strike Fighter, latest generation fighter aircraft. And then in 2006, I came back to Canton as one of the directors at our research and development area, and I've had various roles since I've been back to the one I have today, which is really heading up the whole R&D group. So as I said, again, I'll close just by saying there's a huge need for people interested in technology with technical backgrounds that are going to support manufacturing, science and technology in the United States going forwards. And that's at all levels. I can't hire, you know, guys to run machines out in the machine shop. So those of you, if there's anyone here that's interested in vocational school, you know, I told my kids, I said, hey, if you want a hands-on career, you could do a lot worse than becoming a toolmaker, because nobody, hardly anywhere, is going into that profession. There is going to be a need for toolmakers in the future. So I'll stop there because I could go on for hours, and these guys were good enough to give me a few extra minutes. So I think we're going to open it up to Q&A now, Debbie.
Thank you so much for that, Steve. Like speakers come back up, and we're going to have a panel, and this is your opportunity from our guests that have many years of experience with the Timken Company, and this is your opportunity to think about your careers and what questions you may have, and if I could ask the guests to focus on maybe some project engineering or the importance of teamwork in your positions.
How many people is a part of your team?
I didn't get the question. I can't sit. Do we have to sit down? Can we stand up? Yeah, I'm going to stand up. You can sit down if you want, Rob, but I'm standing up.
How many people? How many people are on your working team?
So my team's 165. How many you got, Rob?
So I have a very small team. I have actually two pieces. I have a direct and an indirect team. My direct team is 4-ish. I think it's actually 4.75 because I have fractions of people. And then my indirect team is a little over 20.
So like Rob, I also have direct team, and then there's a lot of matrix teams outside the United States that we work very closely with. So my direct team is 30 people, and then if you go outside the US for indirects, it's upwards of 50 to 60.
Yeah, as Eric said, Timken is a very matrixed organization. So if you look at people around the world, yeah, everyone reports to somebody, right? So everybody has a boss, but who you report to and who you actually work with and work for can be very, very different, right? Because of the matrix nature of the organization that we have around the planet. So it's really not about just the number of people that work for you. It's really about the influence and the responsibility that you have. So when you look at senior leadership, you will find huge variations, because you look at the guy that's in charge of manufacturing, well, he's got like 16,500 people work for him. But then Eric's really about the future in terms of where we're going as a company, so that's a very responsible position. I'm trying to make sure that we're developing the technologies that we're going to need in the future to allow us to innovate new products and continue to be successful. And then this guy's just trying to keep us all in line.
And I'm trying to find the right people to replace him.
Not possible. All right, come on, more questions. Let's have some more questions. Yes.
Are there any words of advice you have for anybody going into like the entrepreneurship field, or any words of wisdom?
Great question. So, I am not an entrepreneur. I like to think of myself as an innovator. I've got a few patents. From an entrepreneur standpoint, I think the good news today is there's a lot of resources available. So I'm a fan of Kickstarter. Anybody do Kickstarters? Yeah, I got one. Yeah, so this is a crowdsourcing means of funding an idea or a project. You know, one of the challenges for entrepreneurs in the past was always, I've got a great idea, but you always need money, resources to launch any new idea. So I think Kickstarter and crowdsource funding is one opportunity that exists now that's not existed previously.
So my daughter just started her own small business. She's down in Greenville, South Carolina. She's in the communications area. So she went to Ohio U, she went to Clemson, she worked for a company, and she thought, I'm going to go out on my own, I'm going to try that. My advice to you is you have to get up to speed on many different things. So just as we all talked about where we've done different things in our careers, so she's had to become versed in what an LLC is, right? How do you legally set it up? She's had to become versed in how do you keep track of the money? How do you pay your taxes? How do you distribute that money back to herself legally so that she doesn't get in trouble? She has to worry about how does she market herself? She has to worry about, her PC, what happens if it breaks? So how do I start having a fund to replace my PC? So from the entrepreneurial side of going out and starting your business, you have to ask people. There are many agencies to go talk to, like SCORE, et cetera, that will help you set it up and get going. And it is all around being driven, reading, understanding, and setting your business plan so that you can accomplish it. It's really been interesting to watch her do it, because much like Steve, I have not gone down that road. Really a lot of work, but she's very, I'll say, gratified with what she's done with it. by the way, she's actually working on STEM projects, which is science, of course.
So I'll play more of the HR kind of role right now. It's always easy to do somebody else's job. The only comments, so they're great comments from both Steve and Rob. I guess the only comments I will add to that, because marketing, even what we do today, is a little bit what I would call entrepreneurial, right? We try to figure out what people might want or need, and then we have to go over here and try to create it. And the only comments I will make from an advice standpoint is do not be afraid to fail, right? Because if you're not making mistakes, it's very difficult to learn. So you always want to make mistakes. Now, you try not to make the same mistakes twice. That's the caveat with that. And then you also try to mitigate the outcome of a mistake. And the way that you do that is think about what all the possible outcomes are, and then try to put plans in place that will lessen the effects of any of those negative outcomes. All right? And then the only other comments that I'll throw out there for that is you want to think about where you're trying to get to, but you need to start small, right? And actually take it one step at a time and try to carve it up into a small enough chunk that you can try something and then reflect on it and say, what did I learn? Did it work well? If it worked well, let's move faster in that direction. If it didn't work well, then why? What does that mean to where we're trying to get to? How do we change whatever it is we're doing to improve our outcome? And then take another step forward, right? And just keep going until you get to a point where you know you have to stop because it's not going to work. And again, don't be afraid of those things. The sooner you get to those points, and it happens to everybody, the better off you are. And the more you learn on that journey, the better off you'll be for the next thing that you try and the next thing that you try. So it's a general statement, but I think they're very important for people to keep thinking about as you do your job each and every day.
Need, value, conditions. Go on over here. I don't know, this is quite a big room. I like to think I don't need a microphone either, but
Mr. Johnson, you spoke to the importance of young engineers in the future of the States. As experts in your respective fields, who are our international competitors and how do they measure up?
Great question. So, my 40 years with Timken, I have seen a huge change. If we just talk about the Timken company. So when I joined Timken, not to bore you with the details of the products we make, but anybody know what a bearing is? Right, anti-friction device, right? Tries to help to reduce the amount of friction involved in motion. So when I joined Timken, Timken patented one of the early designs of the tapered roller bearing, which was used extensively in machines and vehicles, still is today. But back in the 70s when I joined Timken, if you wanted to buy a tapered roller bearing and you wanted a reasonably good tapered roller bearing, the whole planet it went to the Timken company. That's not the case today. So today, I would still argue, if you want to buy the best tapered roller bearing on the planet, you still go to Timken today. But there's lots of other places I can go now to get reasonably good tapered roller bearings. And in many cases, reasonably good is good enough, right? So this is back to that need, value, and conditions. So it's something to think about from an entrepreneur standpoint. Any opportunity, you can break it down into those three elements. Is there a need? What's my value? Because if there's no value, no one's going to pay for it. And are the conditions right for this opportunity that I'm thinking about? So the competitive landscape today is very challenging. I like to think from our standpoint, we have some technologies that others have yet to figure out, but lots of people are working on those, so we have to continue to work to try and stay one step ahead of the competition. But the Japanese, the Europeans, now the Chinese, lots of emerging competitors in Asia, and the fact that we have continued to make our products perform better and better and better, so that, 40 years ago, something that was an also-ran really wasn't good enough. You put one of these also-ran tapered roller bearings on a vehicle and it didn't get out of warranty. The wheel bearing would fail after 20,000 miles, and now Ford's really upset, or GM's really upset, because they've got a 36,000 mile warranty. Well, those days are long since gone. We can make wheel bearings that go over 1 million miles now. Well, that's that value question. No one's going to pay a premium for a wheel bearing that goes 1 million miles because your average car is done after a couple of 100,000, right? So So yes, the competitive landscape is very intense. It's not going to get any better from our standpoint, but we understand what it is we're trying to do. We have a strategy as a company to continue to evolve our products, and Eric's out looking for new opportunities where our differentiated offering can continue to add value, and moving forwards in that manner is how we'll continue to sustain the Timken company going forwards.
So Steve talked about the hard side. So these two guys' life is to figure out how to make mine miserable.